Let's talk electric current. Electric charge flows from a high voltage to a low voltage. Before the 19th century, scientists had been able to generate static electricity by rubbing different materials together, just like we did in class with the fur in the rod and the fur in the balloon. It wasn't until Italian scientist Alessandro Volta created the first voltaic cell, the first battery, to create an electric potential difference between two metal ends. Just like the battery has a positive and a negative end, when these two ends are connected, current begins to flow. Current is the rate at which charge flows through a given point. When you see the word rate, you should automatically think time, so the amount of charge per second, the amount of charge per time. Current can only be sustained if there is a difference in electrical potential or voltage between 2 points. The unit of current is the ampere or the amp. 1 ampere is equal to 1 coulomb per second. 1 coulomb, capital C, divided by seconds. The equation that we use for current to solve for current is capital I, which is equal to the change in charge divided by time. So capital I stands for current. The change in Q is our change in our charge, the change in the coulombs, divided by T, our time. Typical systems in which current is calculated will include, of course, electrical circuits. That is what we are going to focus on. Particle beams, like rays, and streams of ions, which you will talk about in chemistry, unbalanced charges. Let's do the example 1. 100 coulombs of charge pass through point A every 4 seconds. What is the rate of current flow through point A? They give us 100 coulombs, so they give us our Q. They tell us that we have every 4 seconds. That is our T, our time. We are solving for I. Here is our formula. I equals Q over T. 100 coulombs divided by 4 seconds gives us 25 amperes, 25A. During a thunderstorm, a lightning strike, lightning, an electrical discharge, we talked about lightning going around the plane. We watched the video of the man sitting in the car being struck by lightning. So a lightning strike transferring 15 coulombs of charge in 1 times 10 to the negative 4 seconds. What is the average current produced in this strike? We are solving for current. We are solving for I. So again, our formula, I equals Q over T. You have to make sure when plugging into your calculator, you're using parentheses. 15 divided by parentheses, 1 times 10 to the negative 4, close parentheses, equals, should give you 1.5 times 10 to the positive 5 amperes. Remember, your calculator is only as smart as you program it to be. So if you leave out the parentheses, you are not going to get the correct answer. Our last example, a wire carries a current of 50 amperes. How much charge passes through the wire in 10 seconds? Here, they give us current, so they give us I. How much charge? We are looking for Q. Passing through the wire in 10 seconds, they give us our T. I equals Q over T. We have 50 amperes is equal to Q over 10 seconds. When in doubt, put 50 over 1. If you do not see to cross multiply, make sure you make a fraction on both sides. 50 times 10 gives us 500 coulombs. At this point, we have talked about a lot of different equations, a lot of different topics in electricity. So how many electrons pass through the wire every 10 seconds? We're solving for how many, the number of electrons. We are given Q. We want to know the number N. We know that an electron has a charge of 1.6 times 10 to the negative 19, the magnitude of it in coulombs. If I want to solve for this, I can use the formula Q equals NE. Don't forget the formula, Q equals NE, where Q is 500 coulombs, N is what we were solving for, and E is, of course, your elementary charge. Solving for that, you will get 3.125 times 10 to the 10 to the positive 21 electrons.